Ms.
Thank
Montse?
you. Yes, thank you. Good evening, everybody. This is Montserrat Varas. I'm the person responsible for Genova's office in Madrid. First of all, I would like to thank to Mina Energy Meet for the opportunity to present our company, Ghenova Engineering, our knowledge and experience in two particular business areas, photovoltaic energy and wind energy, as well as our vision for this business and future challenges. Ghenova Engineering is a Spanish engineering firm well focused on renewables projects all around the world. Besides, we have other business areas as energy and industry, infrastructure, naval and offshore, and system as well. So we have over 500 employees working in 9 offices and in 5 countries. So regarding the energy projects, in Ghenova, we cover from renewable energy, non-manageable, as wind power and photovoltaic energy, to clean energy power plants, as waste-to-energy and biomass power plants. In these presentations in particular, we focus on wind power and PV plants. Yes, and I want to drive upon home of the evolution of the design in Ghenova regarding these two technologies, PV and wind. Currently, we have designed more than 7 gigawatts. In the column bar graph, we can see as the number of renewable power plants designed by Ghenova has gone up meaningfully last 3 years. And it will keep growing even more thanks to the objective of the European Commission. There are no net emissions for greenhouse gases by 2050. So the European Green Deal is a plan to make the European Union's economy sustainable. And the European Union's plan is to get it very by turning climate and environmental challenges into opportunities. Ghenova cannot agree more with this vision, and the economic growth must be decoupled from resources use. And on the top of that, we must get it by respecting environmental. So talk about knowledge. So Ghenova offers technical consulting services for lenders, developers, EPC contractors, operators, and owners. As to renewables projects, we support all life cycle for a project, from the investigation phase, promotion phase, construction, and operation. In investigation phase, we highlight selection of location or initial measures campaign. In promotion phase, we highlight micrositing, elaboration of the administrative process project, or equipment selection, monocrystalline silicon PV or polycrystalline silicon PV, thick film or central or string inverters, and so on. In construction phase, we highlight preparation of the constructive project or support of the construction supervision at site. And finally, in operation phase, we highlight operation and maintenance plan and support with workforce at site. Here you can find all the scope of services in detail. Investigation phase. So search of the ideal location for a project. Ghenova has developed an intelligent platform to analyze and visualize data with factors as radiations, slopes, environmental protected areas, and distance to nearest substations. So in that way, all these elements help us to search the ideal location for a PV plant. It's important to make progress and use new technologies as big data for our benefit and for the benefit of the client, for sure. So as well, I would like to highlight analysis of the energy resource available or feasibility studies. And for the next one, for promotion phase, I only want you to remember 2 important services that we can offer as well. All the environmental studies in order to get the environmental permits that a developer requires for its projects, and the elaboration of the administrative project in order to get the required administration permits as well. So in short, we support and accompany the developer along the promotion stage. And for construction phase, in the same way, Ghenova support the EPC contractor and how we design the power plant, we develop the detail engineering, civil roads, platforms, optimize the layout and performance ratio with advanced software as PVKs or PVCs. We are able to develop any kind of document for all the disciplines. We advise as well on the selection of the equipment, of the suppliers, and we offer procurement technical support for the evaluation and selection of the equipment. As well, we provide our large experience in combined cycle and waste to energy in supply chain management, from expediting, logistics, inspection of equipment, control of quality of the equipment, until the satisfaction of the client. And besides, we have a team for the supervision of the construction site as well. And finally, operation phase. Regarding this phase, we can support the operators offering services as operation and maintenance, plant or manpower, warranty supports, failure analysis, and integrations with the network operators. And yes, following, I have brought some specific works that give added value to the client in order to make a project more profitable, as is the case of the accurate design of the wind turbine foundation. We develop specific studies to optimize the solution by using softwares as SAP 2000 or Revit. Yes, as well, we design an optimization of the infrastructure. We have already helped our clients to win auctions, thanks to the optimization of the earthworks or paving structure. Although a client assumes that an engineering company will optimize the design, most of them don't consider any optimization in the design. And this is what we offer in Ghenova. And of course, Ghenova can be your eyes and watch over your construction. We know owner engineering and construction supervision as well. So yes, our experience. So let me skip the project references. As summary, we have designed more than 5.5 gigawatts in wind energy and more than 1.5 gigawatts in PV plants. And here I have some examples. So yes, probably you can pass quickly. So since 2014, we have designed PV plants in countries as Mexico, Brazil, or Spain for clients as Bester or Neoenergia, Solaria, yes, IDM. So for owners, EPC contractors. Yes, this is some of the examples. And this is a list of the projects. And here's an example of wind farms projects. Clients as Elecnor, EDP, or Engie, or Enel, or Força Eólica do Brasil, that is Iberdrola, have trust on us to develop as well their projects. As well in Bolivia, Brazil, Mexico, Spain. Yes, and this is the big list of the project that we have been involved. And this is our best assets, our clients. Yes, finally, the challenge of the future. So one of the challenges of the future for the production of electricity from renewable energies as wind and PV is to manage the production of energy and allow operational flexibility. So this management of the production requires of advanced solution to improve the integration of the renewables, to steady the power output to the system, to use the energy surplus and match generation with demand. And here, Ghenova is an active actor that has developed their own new technology to manage the production of electricity through the hybridization of the CSP and PV. And it is what my colleague is going to explain next, BlueSolar technology. So yes, I don't want to extend much more, and I hope I have been able to show you our capabilities, knowledge, and experience, as well as our vision of the future for the energy.
So thank you, Monse. I'll explain now briefly what Blue Solar technology is. Blue Solar is basically a venture between Ghenova and Capson Technologies, which is a technological Spanish company. Blue Solar is a hybridization between photovoltaic and concentrated solar towers. Basically, we are sharing the solar field, which is the major cause of a PV plant, surely, and also a concentrated solar tower plant. We are sharing the solar field by making the PV panels work as mirrors. So with the optical light selective filter, we are able to convert a standard PV panel with any kind of PV technology in also as a mirror. But it's an intelligent mirror that let go through the glass the energy that PV is using efficiently, maybe the visible light. But now there is a lot of energy, around 40, even 45% of the energy that PV is not using efficiently and actually is overheating the cell. So with this film, we are able to reflect this energy, this 40, 45% of the energy to a concentrated solar tower to be used for several purposes as we will see. So basically our technology is a huge PV plant that also works as a solar field of a concentrated solar tower power plant. And the PV panel performance is very similar to a standard PV panel. And the key of the technology is the efficiency. With the same surface, we are able to provide much more energy than a PV plant and also than a concentrated solar tower plant. So why is important this technology? Well, first application is energy storage. We can use the same kind of technologies that the CSP is using right now, molten salt or the solid storage media, and we can store the electricity in the tower in the same way than a CSP plant, and also producing electricity through the PV as the same way than a standard PV plant. So we'll see some highlights of the LCOE in the next slide, but the other application is the cogeneration of electricity and steam. Two-thirds of the energy consumption in the industry comes as heat. So everybody thinks that the energy consumes a lot of electricity, the industry, but actually the consumption comes two-thirds as heat. So this technology is very good to provide that heat because it comes from a cogeneration of the PV plant. Another application is desalination for thermal desalination techniques. And the match with forward osmosis that is coming is very good as other desalination techniques because the heat supplied by the power plant is very cheap. And also we are compatible with hydrogen because we are able to provide the hydrogen at higher temperature by using a different kind of electrolyzer that are being developed by some partners here in Spain, and the efficiency is better than producing hydrogen at environmental temperature. So this is why the technology we think is important because it faces four of the most important challenges that the world will have to face in the following years. The key features of the technology, well, we've tested in top European technological centers such as PSA, Fraunhofer, CSIRO, or DECRA. The results are very, very well, very good, excellent results. We are able to produce almost the same energy than a PV power plant. We are working on a new solution to reflect even much more energy, up to 55%. Also, we have no degradation of the filters. We extend the life cycle of a PV plant and also a concentrated solar tower plant. And we are based on 3 bankable technology, because PV is bankable, concentrated solar power is bankable, and the filter technology is bankable. But now we integrate all of them in the same power plant, and this is because we are in the process to build a pilot plant with this technology. And about the LCOE, we are much more competitive than electrical batteries. Our LCOE is under 50 euros per megawatt hour, depending surely on the financial conditions and the DNI. And the heat that we can produce is lower. The levelized cost of heat is below 15 euros per megawatt hour thermal, and we are more competitive than natural gas in many countries. And as you can see in the pictures, the color of the panels are blue because we mainly reflect blue wavelengths and also infrared. Infrared, we don't see them, and this is why we call this technology BlueSolar. And but we can see a video if the colleagues can play the video now, and the technology in 4 minutes can be much better explained than I do in this video. So please, if you can share the video with the audience, please.
Play the video.
There is one simple fact that may just change your thoughts on renewable energies. The amount of power from the sun that strikes the Earth in a single hour contains more energy than the entire world consumes in 1 year. Current technologies include photovoltaic plants that convert the sunlight directly into electricity. Photovoltaic technologies are being developed and growing exponentially. However, the electrical production occurs during the hours of sunlight, which don't usually match the demanding times of human activity. Electrical storage with batteries, although being under fast development, is still expensive. On the other hand, there are concentrated solar thermal power plants that utilize the heat of the sunlight using mirrors, concentrating a large area of thermal energy onto a point. This way, the concentrated heat can be stored and released for usage when required. Solar power is anticipated to become the world's largest source of electricity by 2050. In the search for making it viable, Capson Technologies and Ghenova Engineering have developed and patented an ingenious but simple optical light selective filter that permits most of the visible region of the light to go through it and reflects the infrared and some blue wavelengths that, although are invisible to human eyes, can be felt as heat. This filter makes it possible to combine both technologies, substituting the mirrors with integrated filters on photovoltaic panels that continue generating electricity, while also reflecting the heat that is utilized for thermal storage or steam generation. This integration of photovoltaic plants with thermal storage plants makes it possible to utilize the sunlight energy in such a highly efficient way that the cost of electricity can be significantly reduced. Spire technology produces much more energy than current concentrated solar power or photovoltaic plants due to a better utilization of solar spectrum and a better operational performance of the plant, minimizing cosine factor in the operation of the solar field, eliminating the dumped energy because of the operation modes of the plant, and using the diffused irradiation in the photovoltaic panels, and not only direct irradiation as current concentrated solar power mirrors. The selective filter will reflect the infrared and the blue light, protecting from overheating and bringing the temperature down to the optimal efficiency range of the photovoltaic panels. For large quantities of energy, thermal storage is nowadays considerably more economical than using electric batteries. In fact, the projected cost of storage from Spire technology versus electrical batteries could be up to 7 to 10 times more cost-effective. The potential development of electric batteries can be assimilated within the direct electricity production line, as the combination of both technologies, rather than isolating, will complement and bring out the best of each other. Ultimately, the adaptation of the system is particularly relevant in regions where the solar irradiation is high, but available fresh water is still limited. The production of steam for distillation and desalination of seawater adds another dimension to the development of these areas. Renewable energy storage and water desalination are two of the most important challenges that the world will have to face in the following years. Spire Technology is the first of its class that introduces an economical and feasible solution to both challenges.
So thank you very much for your attendance. So if you have any question for Monse or for me, we are really glad to answer them. So thank you.